default for landscape actor, and that would be the sort of usual workflow for applying Brushify to this. Now in this case that won't actually work, and if you do that, what will happen is you'll just get this sort of black, that's quite interesting, but you'll just get this sort of black shiny material. It's really cool to see the screen space reflections there. You'll get this very sort of shiny material. So what we want is to actually create something that's going to allow us to use this and sort of convert this normal landscape material into something the voxels can understand. So I'm going to right click and go to voxel, and we're going to go to voxel landscape material collection. I'm going to click that. And this is going to create something called the voxel landscape material collection. I'm just going to save it. You can call it whatever you like. Call it my landscape or something like that. And just click that and open it up. And then we're just going to drag the MI landscape onto this material slot inside of there. And then just hit save. And immediately you can already see that we've actually got all the layers that are just these sort of 12 layers. And inside of each of those, we can see all the usual Brushify 8 layers. And they've all been nicely replicated for us to sort of use and paint on. So I'm going to close this down now, and I'm going to go back to the voxel world, the details panel, and I'm going to choose from the voxel material section, instead of material config RGB, I'm going to change that to multi-index. And now we've got back that sort of yellow material from before. But this time, I'm going to drag our newly created voxel landscape material collection onto that. And bam, now we have the Brushify auto material in all of its glory with the voxel system. And I think it already looks really, really cool just out of the box. And I think the reason for that is because we've actually got triplanar mapping built into the Brushify auto material. So there isn't really much work that needs to be done on Brushify itself for this to work. If I jump into the MI landscape material with Brushify, and if I scroll down, I disable the triplanar mapping. It's just right here, triplanar. You can just untick it. And you can see how stretched and ugly that looks without the triplanar mapping applied. But just ticking this box, bam, suddenly we have this nice looking triplanar mapping, and everything looks really nice. And there's no vertical stretching anymore on any of the slopes. So yeah, I really think that I got quite lucky here because I just implemented triplanar mapping in the last release of Brushify, and yeah, just surprisingly it moved very, very well with this voxel system. Another thing is that all of the other material features of Brushify also work just fine. So if we go into the distance tiling, for instance, we can change the tiling there, and it all just functions exactly the same as it would on a landscape actor, which is really, really impressive. And we've got the reduced tiling function. You see all this tiling here going on. If I tick that box, reduce tiling, that's working perfectly, that feature, to reduce the tiling on the map and make it look a little bit more seamless. And of course, the actual slopes system is working as well. So if I change this to different slope mounts, you can actually alter the slope and where the slopes kind of appear. So if we want it to be that there's more rock or less rock, or just how much of the rock actually appears, how much grass appears, at what sort of angle does the rock start to come in. So yeah, I'm just going to do that for the default. It looks pretty solid. You might notice the only thing that is really missing is the procedural grass types. Those aren't working. And I actually looked into this and asked the creator about this, and he told me that the Pro version has a procedural spawning sort of system, and they're actually looking into doing a sort of converter of the usual grass type system, so you can convert that system across. I'm just going to do a little bit more sculpting here and use the tool to create some interesting shapes. So let's make this brush a little bigger. Start modeling some crazy mountains and stuff. Little mountains and cool shapes. What's cool as well is that this is all pretty solid. And I'm actually sculpting really large sections in real time. It does appear that it's not that hard to work with. It's not too laggy or anything like that. If you sculpt smaller amounts, it's basically real time. So I really think that they've managed to optimize this system very well. So that's sort of like the.
Я просто свинья, просто хам. Ты на меня так сильно не смотри, мне надо сейчас как-то реализоваться там, да. Пока денег-то нет. Я себя ищу как. Скажем так. Ну нет, это все, конечно, вранье. То есть ты, конечно, то, что слушал, это все вообще, да, полностью. Отомсти.
But yeah, you can basically switch between the 4 different channels, R, G, B, A, and you've got the brushify brush, just drag and drop that in, and I presume that that would work pretty well. So yeah, I'll definitely be trying that in the future. And yeah, so you've got surface sculpting, basically the sculpting brush. You've got smooth. With this one, you have to be careful because it will smooth very, very rapidly if you have it on the default settings. I had to sort of crank that really far down because we look really strong. So I found that really low values on this work really nicely, especially if I had something like this. If I had a shape where I've done something really detailed and kind of spindly. If I wanted to basically like reduce this and make it a little bit less bulbous, you can see how strongly it affects things. So bring the number of iterations down and the strength down, and then we can go lower, and then it's a lot more easy to handle.
Это еще обиднее, понимаешь, у них какие-то реальные дела свои какие-то, да, понимаешь, еще я к тому же. У меня тоже должны быть реальные дела какие-то. Где мои реальные дела? Резняк просто все, да, я понял. Неизвестно, как делается, да. Это все халява, просто на халяще просто, да. Я понял, порядок, я понял.
A mesh, but that also uses the Pro version. Sphere, this one is really cool because what I can do.
Hello everyone, my name is Victor Röhrman. In this tutorial I'm going to cover how I went about creating this environment. It was created in an afternoon and is made entirely using Megascan's 3D assets and materials with the exception for the terrain. I'll be going over how I made that as well. The first thing I'm going to do is create the path, or the road, and I'm going to go for a vehicular type road with clear tire tracks.
Давайте я расскажу о своем эксперименте в области кинетических алгоритмов.
As with most things, the process is very simple and it's more about the materials and its presentation that matters rather than the geometry itself. all I'm doing here is making sure the general shape is good and that it tiles well once I start adding some irregularities to it. I'm also making sure it's pretty evenly tessellated so that it can be displaced nicely in Unreal Engine. And I think this looks good, so let's move on to creating the sides. Same thing goes for this model. Very simple, evenly tessellated geometry that has an interesting base shape, while making sure it repeats and tiles nicely. I want the model to go outwards and upwards a bit, allowing me some space to place the dense, highly detailed vegetation and scatter assets near the path. Around this area I'll just use Unreal terrain, so this will cover that nicely. The reason for not using Unreal terrain for the entire scene is that this, while adding some challenges, gives me more freedom and options. You could do it both ways, but this is my preferred workflow for scenes like these. When UV mapping these modules, I try and keep them within the 0 to 1 space, and also as a single UV island with no cuts. Right, time to head into Unreal. Alright, so what we have here are the meshes that we just made, and they are completely untextured. So, what I want to do now is take a look at the material. I have a master material that I usually use for scenes like these, which allows me to vertex paint and do some cool blending. So let's open up the material and take a look at it. So, this really is just a basic vertex blend material. We have this vertex color node here, just red and green channels, and we're doing a multiply and a power here, just intensity and masking power. And the same thing goes for this one. These are the exact same, except I haven't commented this one for clarity. And these are just plugged in to the lerps, which blend the different textures. And the same thing here, we just multiply with vector node here, we can tint them, and it's pretty much basic stuff here. There is a small difference here from the most common vertex blend materials, and that is the noise mask here. And
seems there's no other place in the universe with a dense atmosphere. Mountains, sand dunes, plains, lakes, rivers and oceans, except the planet Earth. But it turns out there's actually a place much like the Earth in our solar system that has a complex weather cycle, landscapes carved by liquid and volcanic activity. It may even resemble the Earth in its earliest stages, and some scientists think it might be better to colonize it first instead of Mars. This is Saturn's moon, Titan. Recently, something bizarre was found hidden in its orange clouds. And because of this, NASA is now planning a mission to Titan. But what did they find? And why was it so important? Before we get to that, let's learn a little about this strange world that orbits Saturn. Our solar system is home to more than 150 moons, but only 4 of those have an atmosphere. One of those is Titan, the second largest moon in our solar system and the largest moon of the planet Saturn. Titan is also the only place in the solar system other than the moon of the planet Saturn. Titan is also the only place in the solar system other than the planet Earth that has liquids on its surface. It has a weather cycle much like ours, but has clouds that rain frozen liquid methane and ethane instead of water. Titan could be the best place for human colonization. In fact, the conditions are right for a self-sustaining, long-term human settlement. Titan is a remarkably Earth-like world that has a thick atmosphere, about 4 times as thick as Earth. The atmospheric pressure is about 60% greater than on Earth. Imagine swimming 50 feet underwater to give you an idea. This means you wouldn't have to wear a bulky pressurization suit if you were walking around on the surface. The atmosphere would also keep out deadly radiation, energetic particles from the sun, and galactic cosmic rays from making it to the surface of Titan, making it a safe environment for humans. Mars doesn't have such protection. People living on Titan could walk or bounce around since gravity is only 14% of the Earth's. If you strapped some wings on yourself, you could literally fly around under your own power. But it's very cold on Titan, because on average it's 886 million miles from the sun. You would need a suit to keep warm, because the surface temperature is about minus 290 degrees Fahrenheit, and the only sunlight that reaches its surface is like late sunsets on Earth. Of course, you'd also need to wear a respirator to breathe. Titan is tidally locked to Saturn, meaning one side always faces the planet. It's 759,000 miles away from Saturn and has a radius of about 1,600 miles. It takes Titan 15 days and 22 hours to make an orbit of Saturn, and 29 Earth years to make a complete orbit around the Sun. No one is certain what Titan looks like under the surface, but on January 14, 2005, the European Space Agency's robotic lander Huygens made a dramatic descent through the Moon's orange smoggy atmosphere and landed on the surface of the Moon. The camera on Huygens shows a desolate-looking surface and captured the trademark yellow haze, which revealed intricate details of the atmosphere's layers, winds, and mysterious chemical processes. Based on data from the Cassini-Huygens mission, Titan has 5 primary layers of rock. The soggy Moon has a core of water-bearing silicate rock surrounded by a shell of special water ice called Ice 6 that's found only at extremely high pressures. This high-pressure ice is surrounded by yellow haze, which revealed intricate details of the atmosphere's layers, winds, and mysterious chemical processes. Based on data from the Cassini-Huygens mission, Titan has 5 primary layers of rock. The soggy Moon has a core of water-bearing silicate rock surrounded by a shell of special water ice called Ice 6 that's found only at extremely high pressures. This high-pressure ice is surrounded by a layer of salty liquid, and an outer crust of water ice sits on top of this. The surface is coated with organic molecules that have rained or settled out of the atmosphere in forms of sands and liquids. The presence of lakes and seas on Titan brings up an interesting question. Could there possibly be any forms of life there? In 2005, scientists at the Southwestern Research Institute in Texas and Washington State University said that several of the crucial elements for life on Earth are also on Titan, even though the conditions are far harsher than Earth. Some life forms are a lot tougher and stranger than we think. Take, for instance, Deinococcus radiodurans bacteria, an extremophile that was in outer space for 3 years outside of the International Space Station, enduring...
A video editor for all creators.
What you doing there?
microgravity, harsh ultraviolet radiation, temperatures near absolute zero, and still managed to survive. If there's life on Titan, it could be hidden underground, and a lot weirder than we think. The Cassini spacecraft revealed that the moon is hiding an underground ocean of liquid water mixed with salts and ammonia. Titan could potentially have environments with conditions suitable for life as we know it in the subsurface ocean, or bizarre alien life that we don't know about yet in a hydrocarbon liquid on the surface. But what happened there recently that drew our attention there? In 2016, a team of scientists identified a molecule called cyclopropenylidene, C3H2, in Titan's atmosphere that's never been detected anywhere else except deep space. The discovery was made using the Atacama Large Millimeter Array, ALMA, that's made up of 66 radio antennas. These all work together to create a single giant telescope. ALMA uses a technique known as interferometry, where all antennas are pointed at the same point in the sky. The antennas pick up a signal from the target in the universe and join forces to analyze the signal. By combining radio waves from the antennas using a supercomputer, researchers can obtain extremely high precision images. In order for ALMA to get these images, there must be a perfect synchronization between all 66 antennas and the electronics with the precision of a millionth of a second. Using this incredible technology, researchers found something they didn't expect to find. A weird molecule called cyclopropenylidene. C3H2 is a strange organic molecule that doesn't exist terrestrially on Earth and can only be seen in a laboratory. C3H2 was first discovered in clouds of gas and dust throughout the Milky Way, including the Taurus molecular cloud. This simple carbon-based molecule may be a precursor to more complex compounds, and it could form or even feed possible life on Titan, like organic molecules that formed life on Earth between 3.5 and 3.9 billion years ago. C3H2 is the only other cyclic or closed-loop molecule besides...
Может, он смешной. Женя Маратовича. Маратович смешной. Вы за все заплатите, понимаешь? Ну, то есть, как бы, да. Я не знаю, мне плевать просто, да. То есть, да. А что ты хочешь? А что? Тогда не надо всем бесполым быть тогда. Как прожить свою жизнь так, чтобы было счастье, чтобы хорошо было? Вот я ни за что не поверю. Вот жизнь меня заставляет мужскую работу делать, если ты женщина, да? Или меня заставляет быть добреньким, да? Просто так и говоришь, что ты слабак, да? Я вот слабак, например, я понимаю. Да, понимаешь. Ну, не вот это, денег нету, я неадекват просто. Потому что семья у меня такая, наверное. Да, ногами пинали детство, как жизнь. Ну, эгоизм, неважно. Да, похлопать. Да, все равно, ну, счастье мужика это когда, ну, я тебя понял. Ну, таких не бывает людей на свете, таких. Ну, смотри, есть какой-то вот за горизонтом там счастье. Да, все ведь понимают, что есть какая-то сторона улучшения. Правильно? То есть, ну ты не понимаешь, но ты бы хотел, чтобы, как бы, ну это уже как-то лукавый, да, что ты внукам там, да. Ты не понимаешь, но ты понимаешь, что если бы ты работал, то было бы веселее, наверное. Да? Понимаешь, что как-то это возможно, все-таки, да, понимаешь, да. Вот оно может как-то так и устроено, что ты не женщина, ты делами занимаешься, домой, ты все равно где-то ночевать надо, правильно? Какой-то быт у тебя есть, правильно? То есть и так далее, да. В принципе, да, понимаю. Да, типа того. Надо решать, что будет в быту использоваться, потому что это тоже как бы у нас не очень чистый быт. Можно это, да, и так далее, да. То есть это тоже кто-то должен делать, понимаю. Кто должен делать, кто-то должен думать, решать, и так далее, да. Женщину, наверное, она будет решать, думать, да. И деньги тратить на это. Возможно, свои. Нет, свою зарплату то он должен. Понимаю. А если вот она здоровая, тогда этих вопросов вообще не возникает, понимаешь? Да. Не настораживает тебя это никак? Нет, нет. Ну это несчастье тогда это получается. Никто, ну а даже кому-то подумать. Вот я подумаю, хотя бы. Ну как бы, ну сделай выводы, значит. Лучше не быть, то есть я не здоровая, значит я счастливая, правильно? Нет, я не счастливая, значит я здоровая. То есть у меня нет детей, значит это больше счастья. Да, то есть у меня будет больше. Ну как мужик я примерно могу понять, хотя тоже не факт, понимаете, да. Потому что надо как-то нормально. А общество тебя не принимает, если ты одинокий, как бы, понимаешь, да, да. Как минимум даже так, да. Да. И ты, кстати, не в теме. Вот здесь всякими, да, просто ты как бы не понимаешь, он тебя просто. Да. Ну да. Ну понимаешь, короче. Не можно все забыть.
As benzene to have been found in Titan's atmosphere so far. Closed loop molecules like it are important because they form the backbone rings for the nuclear bases of DNA and RNA, which is also...
Незаперная лопата, говорит, ну ты же молодая еще, правильно? Совсем, ну, да, если найдешь себе какой-нибудь, если хорошо ищешь, там да, там, вот недвижимость прям вот, да, понимает. Примерно как я, Женька, Губаев, можно, да, понимаю. Как по-настоящему, да. Да, что правильно говоришь. Никто не радуется от того, что ты сидишь без работы, один тут, и что-то, ну ладно, болтать это бла-бла-бла. Все-таки это мужская кора головного мозга там, ну хоть что-то понимают. А что, не щебечут как эти? Ну реклама, ну вот видишь, жизнь такая злая, как бы, все так хорошо прям такое-то, да, ну все по земле ходят, ну все тут, типа того, да. Мама дай, мама дай, да, вообще просто, да, следующего рожать значит надо, тогда нормально будет, может, иду, да, понимает. Нет, нет что ли, нет, без всяких, просто так, да. Нет, тебе-то хуже будет, понятно. А что значит жить для себя? Понимаешь? Ну, по-любому, короче, это, да, понимаешь. Их само, понимаешь, если ты такой раз, она такая, я для себя пожил, ты сделал так себе, она для себя живет, как будто бы, да, ну, к примеру. Она сама не рада этого, сама тебя проклянет 1000 раз, потом еще за это. За что она понимает. Это жизнь, я понял уже, да. Ну, вообще просто говорит. Да, ладно.
However, C3H2 is not known to be used in any modern-day biological reactions. NASA says the molecule could be an indicator for life, since something has to be generating an unstable molecule. If there is life on Titan, it would be incredibly different from water-based life forms we know of. NASA was so intrigued by its new discovery on Titan that it wants to study the moon more and announced the Dragonfly mission in 2019, which is planned to launch in 2027. It'll take 9 years for it to reach Titan, arriving in 2036, and will cost a total of $1 billion, including its ride into space. The Dragonfly is a very unique spacecraft design, and is much like a large quadcopter drone, with 2 rotors on each of the spacecraft's 4 corners, hence the name Dragonfly. When it arrives at Titan in the year 2035, it'll need to travel to different areas for study. The Mars Curiosity rover used special tracks to roam the red planet, but with Dragonfly, scientists decided to take advantage of the moon's low gravity with a flying vehicle. This will be the first time that NASA will fly a multi-rotor spacecraft for science, and Dragonfly will be able to make vertical takeoffs and landings. Despite the lower gravity on Titan, it still needs electricity to fly around. So the Dragonfly is equipped with a radioisotope thermoelectric generator, a type of nuclear battery that converts heat from decaying plutonium-238 into electricity. This means it could fly and operate on Titan for decades. Since Dragonfly can easily fly around, it can be moved so that it's always facing the Earth for direct communication, which takes 70 to 90 minutes each way, since Titan is so far away from the Earth. During its proposed 2.7-year mission, Dragonfly will take advantage of the dense atmosphere that'll keep cosmic rays and radiation from destroying it. And it will fly to many different locations to pick up surface materials for chemistry experiments. It'll also check out the planet to see if it's possible for humans to inhabit it one day. Since the building blocks of life, or the organic molecules on Titan, are expected to be similar to those on Earth before life arose, Dragonfly will help study how far pre-life chemistry has progressed to see how life evolved on our own planet. See, we have no idea how life really formed and began on our planet. All we know is that it involved organic molecules. Dragonfly will check out the moon's atmosphere, what the surface is made of, and the ocean that lays below the surface, looking for complex organic materials that are the keys to life. Now, the only thing left is to build the spacecraft and get it ready to launch. Even if we don't find what we're expecting there, the Dragonfly mission will show us a lot more about Titan. It seems that we may soon find life on another planet or moon, and that'll be a very exciting time for science and humanity. What do you think we'll find on Titan? Let us know in the comments. To stay up to date on all the amazing things happening in our universe, make sure you subscribe and turn on notifications, and you'll know the moment a new video arrives. Thanks for watching.
Давно же так жили уже, да, ну наоборот, да. Ну а как? Ну ладно, гипотезы, тем не менее, понимаешь? Да. Будет же так, я не знаю, да. Да, храмы какие-то, там, фантазии, там, божьи какие-то, черт знает, не знаю. Да. То есть это все создано руками, да, нет, а кто делать-то будет? Ну да. Воображение это не то. Но если воображение, тогда давай посмотрим наши любимые фильмы. Понимаете? Интересно, да. Но это не то уже, да. Ну, тут как бы все вместе, видимо, как-то, да, с продолжением, да. Круто. Ну да, а кто будет? Ну, все как бы, ну ты чё? Он тебя понял. Там же прямо так и сказано. То есть, ему вообще на все плевать, а ангелы вокруг него, они что-то там, да, ну да, это все, да, как бы, да, ну, как бы так скажем, да. Все остальное, да. У него ни воли нет, ничего вообще, как бы, типа того. Ну, как-то так, да, я понял. Ну, да. Ну, по идее, есть какие-то направления, да, например, типа того, да. Да, ну, понял, что, да. Да, ну, неважно, это сила бытия, я просто так уж, да. Во что бы ты, как говорится, нет, самое, не убирался, ты хочешь что-то. Наоборот, но мне не касается это, а вообще в целом, да. Да, ну он себе так говорил, да. Это просто не доказано, и скорее всего как-то так. Большая плохие, короче, понимаете. Ну, наверное, все равно есть какие-то такие вещи, моменты, наверное, да. Ну, это уже не надо, это за горкой просто. Ну, нет, ну, он тебя знает уже просто. Ну, наверное, нет, понял он тебя, да. Ну, вот, нет, понял. Да. Наверное. Наверное, да. Ладно, вперед. Ну, да. То есть как бы все от тебя только, то есть от твоей воли зависит, твоего инициума, то есть, да, твое желание, да. Все, ты не да. Ну,
Так, пропусти это видео, если ты не предприниматель. Оно только заберет твое время. Здравствуйте, меня зовут Александр Высоцкий, я основатель и акселератора бизнес-бустер и консалтинговой компании.
This video was sponsored by KiwiCo. More about them at the end of the show. On February 15th, 2013, over Chelyabinsk, Russia, an asteroid heavier than the Eiffel Tower slammed into the atmosphere. And then, 30 kilometers above the ground, it exploded. This violent event was brighter than the sun, but so high up that it was silent for a full 90 seconds after the blast, which only made the devastation worse.
So you see all these videos, people look at what was that? They see the smoke trail in the sky, that's amazing. And then, just when you think nothing's going to happen, the shockwave hits and it blows out the windows. 1,000 people got glass in their face and their eyes because they're looking through the windows.
The shockwave damaged thousands of buildings and injured 1,500 people. What makes the Chelyabinsk incident kind of embarrassing is that the very same day, scientists had predicted that an asteroid would make a close flyby of Earth. And they were right. 16 hours after Chelyabinsk, a similar-sized asteroid, known as Duende, came within 27,000 kilometers of Earth's surface. That's closer than satellites in geosynchronous orbit. But while they correctly predicted this close approach, they completely missed the unrelated asteroid that exploded over Russia. And the truth is, this happens all the time. We're really not that good at detecting asteroids before they hit us. Since 1988, over 1,200 asteroids bigger than a meter have collided with the Earth. And of those, we detected only 5 before they hit, never with more than a day of warning. With all our technology and all the telescopes across the Earth, not to mention the ones in space, why do we struggle to detect dangerous asteroids before they strike? What are the chances that a big asteroid will hit, wiping out most, if not all, life on Earth? And if we saw one coming, what could we do about it? Asteroids are the leftover debris from when our solar system formed. 4.5 billion years ago, rocks and dust clumped together into molten protoplanets. Inside, heavy elements, metals like iron, nickel, and iridium, sank into the core, leaving lighter silicate minerals on the surface. Some of these protoplanets grew into the planets we know today, but many more collided with each other, breaking into pieces.
Нет. Что делать тут перед ним? Что за звук? Мужик. Вот нервно, да. Что прикажете делать? Что? Ну ничего себе, давай.